The first section in 6.7 is going to review defining congruence and similarity. This is what Module 7 will be about. So the next module that we are going to do, we will be going over more specifics and using the statements. On your assignment today, I want to ask you, what do you know about two figures that are congruent? Congruent means the shape has equal sides and equal angles. It will be the exact same shape. It might be moved or rotated, but all of the sides stay the same and all of the angles stay the same. When we are identifying that it is congruent, there are 5 different ways. We can prove it is similar, or congruent, by side, 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 angle, side, angle, side, angle, 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 side, and HL, which looks really weird. It's hypotenuse and the leg. It's specifically for right triangles, which you probably haven't seen as much. We usually see side angles. We usually see these 4 first. Have any of you seen these congruent statements before? Yeah, they look a little familiar. In Module 7, we'll go into looking at pictures so you can see what they look like when they're congruent by these. The next question it will ask is when a figure is similar. Does anybody think they know why a figure would be called similar and not congruent? Yeah, why do you think?
Is it like the same shape with different lengths of size?
Yes, good job. So the same shape with different length of sides. The angles, I'm just going to make a little note. The angles would still be equal. The angles would not change size. It's just the side lengths. I'm just going to draw a picture to show you. You don't have to draw it. But if I had a similar triangle, if this was like 2, 4, and 6, my triangle to be similar would have to be 4, 8, 12. Why would I be able to say that this 2, 4, 6, 1, 4, 8, 12? All of the numbers doubled, right? 2, 4, 6, 4, 8, 12. They are similar because they are different sizes. Same shape with different length of sides. I'm going to make another note. Besides, the angles will still be equal. The sides will be proportional, which is a new word that you will learn. Proportional means if I did a fraction of 2 over 6, what would be proportional to 2 over 6? 4 over 12, because they're the same fraction. 2 over 6 is the same as 4 over 12. It's just been reduced. That's what proportional means. The way we can define if a shape is similar is by having 2 angles. If you know 2 of the angles are equal, the third one would have to be in a triangle. So angle, angle, side, angle, side, and side, side, side. With proof that the sides are proportional. So on your assignment, you do not have to use these. You are not using them. It is just a little glimpse at what we're doing next unit. You can type this exactly in word for word on your assignment when you get to these ones. Are there any questions? Okay, I'm going to draw in. Do you see how I drew similar triangles? If I drew congruent triangles, it would have to be a 2, a 4, and a 6. The side lengths could not change. They would have to be equal sides if you want an image to help you see what congruent is. In our next section, we are going over classifying quadrilaterals again, based on properties. I'm going to draw a picture of each, and then we will talk about what they have in common. A square, all sides are equal with 90 degrees. A rhombus is like a square, but it has been shifted, so it no longer has the 90 degrees. Rectangle has 90 degrees. Parallelogram is a rectangle, and it has been shifted. Okay. The first thing I'm going to do is write the rotational symmetry. So how much do I have to rotate it for it to land on itself? I'm going to use a clear sheet. Here's my image. If I rotate it, I'm going to rotate it 90 degrees, so that's one time around. What happens when I rotate it 90 degrees? Does it land perfectly on top of itself?
Yeah.
Yes, so the square would only have to rotate 90 degrees to land on itself. I'm going to try it with the rhombus, see what happens. Okay. I'm going to rotate it 90. Does it look the same?
No.
No? I'm going to rotate it another 90. Does it look the same?
Yeah.
Yes. How much is that if I have to do it twice?
180.
180. Oh, my bad. What do you think a rectangle will be? Do you need me to draw it and show you the rotation? 180. And a parallelogram. 180. Now on your assignment, it'll ask you for which one rotates 180 degrees. How many are there that rotate 180 degrees? 3 of them. Now this is, I'm going to try my best not to confuse you. What is specific about a rectangle? What are the rules? It has to have 90 degrees. Could I call a rhombus and could I call a parallelogram? Parallel. Could I call it a rectangle? I could not call it that because it has to have 90 degrees. What's the rule about a rhombus? It has to have all 4 equal sides. Does a rectangle have all 4 equal sides? Does a parallelogram have all 4 equal sides? No, I can't call it that. What about a parallelogram? What are the rules of a parallelogram? Parallel sides. Does a rectangle have parallel sides? Parallel? Parallel. It does. Does a rhombus have parallel sides? Yes, so I could define all 3 as a parallelogram. So when it asks you which one rotates 180, parallelogram is the word that you can use to describe all 3 as a group. I'm going to put a little star by it. So if you get that on your assignment, it's not too crazy. Okay, next let's do lines of symmetry. For a square, how many lines of symmetry does a square have? Do you care if I draw it right on it? Maybe I'll draw it off to the side. Here's a square. I could draw a line through the center, through the side, through the diagonal, and through the diagonal. 4. What about a rhombus? How many ways can I fold it? Oops, looks a little weird. So that it folds perfectly in half. If I fold it in half through this line, this corner would be off. So I can't fold it here. If I fold it down the center, this corner would be longer. What about the diagonal? Yes, it is. 1. My picture here looks a little off. But if I folded it right down the middle, these 2 are the same length, so they would end up folding on top of each other. What about a rectangle? I could fold it hamburger, hot dog. Those would be lines of symmetry. If I fold a rectangle down the diagonal, this corner would be off. It wouldn't be a line of symmetry. So this one only has 2. Parallelogram. If I fold it down the center, this would be longer. When I look at the diagonal on it, when I fold it on the diagonal, see how this has 1 arrow and this has 2 arrows? This would not match up because this one would be longer. Diagonals. Do you remember the table from yesterday? A four-sided, in the table, if you look at four, it has four sides. How many diagonals would it have? Four sides from the table.
Number of diagonals, right?
Yep. Two. So all of these have four sides. That's why they will all have two diagonals. As you look through, a square are its lines of symmetry matched with diagonals? Sorry, that's wrong. They are. The diagonals are also lines of symmetry. They would fold it in half perfectly. What about with our rhombus? Are the lines of symmetry the same as the diagonals? Yes, they're in the same spots. What about a rectangle? Are they the same? Lines of symmetry? Diagonals. They are different. And for my lines of symmetry, diagonals, they don't match either. So these are the two that match. Do you have any questions? All right, turn the page. We are going to only do the left three. So cross off the right. You can scribble them out if you want. You're only going to do three of these. For the first one, when it asks for the slope, I will do y minus y over x minus x. You may pick what number you use first. I'm going to use the -8. -8 minus a -7 over -2. I have to use first since I used the -8 minus 5. When I simplify, -8 plus 7 is -1. -2 minus 5 is -7. What do two negatives do? Equal positive. So when I type it in on my computer, I'm just going to type it as 1 over 7. I don't know if it will be mad if you put both negatives, but I would just get rid of them to be safe. Then for the distance. Does anybody remember what I do with the 1 and the 7?
You flip.
Oh, that's for perpendicular. Flipping it is for perpendicular. I'm going to do something else. A squared plus B squared equals C squared. I'm going to plug 1 and I'm going to plug 7 in for the A and the B, for the side lengths of my triangle. 1 squared is 1. What is 7 squared? 49. Those added together make 50. How do I get rid of the power? Square root. So my answer would be square root of 50 for the distance. second one. Can somebody set the top up for the y minus y?
-1 minus
-1 minus -2. All right, somebody else, will you set up the x on the bottom? Sienna, can you set up the bottom? Yeah, perfect. Good job. Now, what will the top become when I combine the 1 minus the -2? Do any of you know what it would be? What was it? 1. 1 on top. And the bottom, -6 minus a -3. Good job. -3. This would be my slope that I enter in. But then I have to find the distance. So I would type 1 squared plus -3 squared is c squared. 1 squared is 1. What's -3 times -3? 9. 1 plus 9 is 10. Square root it, and there's your answer. That's my distance. And it just wants you to leave it in exact form. It does not want you to type it in and find the decimal. Last one. Do you think you can do it on your own? Try it on your own. I'm going to freeze it. And I'm going to do it too, and then we'll compare our answers. Don't reduce your fraction on this one. Don't reduce the fraction. Who wants to share the fraction they got? Not reduced. What'd you get?
15/-5.
Okay, who else got that? 15/-5. That was good. The reason I don't reduce is because I want to use that 15 and the -5 in the distance formula. If you type it in on your homework as -3, do you think it'll mark it wrong for the slope? It would not mark it wrong for the slope. If you were to put -3 for slope, it would be fine. If you put 15/-5, it'd also be fine. Who found the distance already? What'd you get? 250 what though? The square root. You have to put the square root on it. So I'm gonna unfreeze maybe. It's not like to freeze. I broke it. does not want to see the work, but come on, you can do it. You can start on your assignment if you'd like. Yeah, what's your question?
You can see if you can finish the online.
Yeah, there we go. It just wasn't unfreezing for a second. So we would do 8 minus -7, which gives us 15. 0 minus 5 gives us -5. If you type it in like that on your homework, that is good. If you type it in as a -3, that also works.
So you don't need
I do. So the reason I left like this is so that I could substitute 15 and the -5 in to find this. I will leave it up there so you guys can copy it.